Hey everybody! Alright, what we're going to be talking about is z-scores. So in my previous video, I talked about the normal distribution, and now what we're going to start talking about is what's called the standard normal distribution and z-scores. Let's get it started. Alright, so for z-scores, what they are, it's a standardized value that indicates the number of standard deviations a data value is above or below the mean. When it comes to the formula, here's what we have on the right side. Here's kind of without it being in fraction form, I suppose. So we have x equals mu plus z multiplied by sigma. So x is going to be a particular data value. Mu is going to be our mean. You may be using a different notation for mean. You may be using x bar, and that's totally fine. Z is going to represent our z-score, and sigma is going to be our standard deviation. We can manipulate this formula into the one here, isolating z, and then we can calculate our z-score that way. All right, next, standard normal distribution. What the standard normal distribution is and how it's different to just whatever a regular normal distribution is. So a standard normal distribution, it's still a normal distribution. I feel like I've said normal distribution 100 times at this point. That's okay. It's a normal distribution that has a mean of 0 and a standard deviation of 1. I'm going to show you what that looks like on the normal distribution curve. All right. So we have our bell curve here. When I go to input the standard normal distribution, in the middle is going to be my mean, which is 0. Next, when I input my standard deviations, they're going to be increasing by 1 as I go up on the right and decreasing by 1 as I go to the left. So notice that we can have positives and negative z-scores. The numbers along the bottom here are what's going to be called the standard normal distribution. And what this allows us to do is to take any type of data that would be able to be written as a bell curve or normal distribution and talk about it with a common language. So here's a good example. When we talk about IQ scores, IQ tests are really not a great way of testing intelligence, but it's a really good example when we're talking about this. For IQ scores, the mean is 100, and for most of them, the standard deviation is 15. So if I was to put that on top of what I already have here, the mean would be 100, and then I would increase by 15 as I go up, and I would decrease by 15 as I go down. Like so. What we can now start talking about is how does this compare to the standard normal distribution? So what I have along the bottom here is just a regular normal distribution. And then what I have above it is the standard normal distribution. So we're standardizing it, kind of like a standardized test. It's a way of making everything kind of the same. When I start to compare these, I'm just going to quickly switch my color here. When I go to compare these, what I would say is let's pretend I took an IQ test and I said I got a mean of 100. Well, then that means that I got a z-score of 0. I'm right on average. Well, if someone told me, okay, well, you got -2 standard deviations away from the mean on the IQ test, well, then that means that I scored 70. If I scored +2, then I scored 130 on the IQ test. So it's a way, all of these numbers kind of going from -3 to +3 is just a way of standardizing. It's saying how many standard deviations away are you from the mean? Let's take a look at an example of where we can use this. On an exam that had a mean of 65%, a standard deviation of 2.5, you received 66%. Calculate your z-score. Let's start with our formula. So we have z equals x minus mu divided by sigma. All right, well, my z-score is going to be equal to x, which is what is the particular value that we got on the test, which is 66%. What I want to subtract from that is mu, which is my mean. And then lastly, we want to divide by the standard deviation, which was told to us at 2.5%. What I get here for an answer is 0.4. So what this means is that I performed at 0.4 standard deviations above the mean. Let's try another example. This example is going to require that you know how to read a Z-score table. If you already know how to do so, you're good to go. But if you don't, please click the link that I've just provided here on the screen in order to learn how to do that first. So pause this video and then come back. On an exam that had a mean of 63.5% and a standard deviation of 5.3, determine the probability that a student scored between 50 and 60%. First, let's start by looking at our formula. Z is equal to x minus mu divided by sigma. In this particular instance, what I have is I have two different particular values that I'm caring about. So these are going to be kind of two different x values. Let's call it x1 and x2 for now. The mean is 63.5 and my standard deviation is here. What I want to know is kind of determine the probability that a student scored between these two values. So this is going to require my Z-scores table. First, let's actually find the Z-scores. So my first one, I'm going to input my first x value of 50. Plugging this into my calculator, what I get is, when I round to the nearest hundredth, the answer I get here is negative 2.55. Let's find the other Z-score. What I get here when I round to the nearest hundredth is 0.66. All right, what we need to do is go to our Z-score table. So take a look, pause this video, go look at your Z-score table and find those two values that are representing those Z-scores. Come back when you're ready. All right, here's what I got from my Z-score table. So when I looked at the Z-score of negative 2.55, I had a decimal of 0.0054, and the Z-score negative 0.66 had a decimal of 0.2546. In terms of percentages, these represent 0.54% and 25.46%. Next, what I want to do is before I kind of get to my final answer, I want to visualize what's going on here. So I'm going to draw my normal distribution. Okay, here's my normal distribution. I've input my mean and I use my standard deviation to come up with all of these values along the top here for positive 1, 2, 3 and negative 1, 2, 3 standard deviations. If I want to know the percentage or the probability that a student would score between 50 and 60%, this is roughly where 50 and 60 would be on my bell curve. What I'm looking for is what is the probability that a student scores anywhere in between this. When you read a Z-score table, what you're getting is the probability that the student would be scoring below this particular Z-score. So for example, when I was looking at 50, I had this Z-score, which was now right here, negative 2.55. When I got the percentage of 0.54, what that means is that 0.54%, or I guess there's a 0.54% probability that the student scored below 50. So they're kind of looking at this section. If we now look at the next part, Well, we had at 60%, that was representing a z-score of negative 0.66. And as a percentage, we had 25.46. So there's a 25.46% probability that the student would score below 60%. So what we've kind of done is counted this little piece twice. If I color it in just to kind of reiterate this, when we were looking at the first part, this from here to here was representing 0.54%. This section here is representing 25.46%, everything below here. So notice that I've double counted this section twice. So that means that I need to subtract these two percentages. So let's go ahead and do that. So 25.46, take away 0.54. We get 24.92%, and that's going to be our final answer. So what this means is that we have a 24.92% chance of this student scoring between 50 and 60%. Let's try one more example. Our last example. You score 65% on an exam that had a class average of 60%. If 17.88% of the students in your class performed better than you, what was the standard deviation of this exam? All right, what I want to start with is drawing a normal distribution for this situation. All right, here is my normal distribution. I've input my mean, my class average, which was 60%. I scored 65%, and what I know is that 17.88% of all the students in the class, this percentage of people scored better than me, so they were above me in the bell curve. What I don't know is what z-score does this happen at. I also don't know what the standard deviation is, and that's what I'm trying to find. So if I look at my formula, I have a particular x value, I have a mean, but I'm missing a z-score and I'm missing a standard deviation. In order to find a z-score, this is where I need to use my z-score table again, and I want to use the percentage. Let's convert that into a decimal. And let's go find that decimal on our z-score table. Before we do that, what you need to remember is that any z-score table is going to tell you the percentage below a particular z-score. So when I go back to here, my picture, it's going to tell me these percentages. It's going to tell me a percentage below a particular z-score. So what we need to do first is take away 17.88% from 100. Which will be 82.12%. All right, let's go find this decimal in our z-score table. Pause the video, go take a look, come back when you're ready. If you read your z-score table correctly, you should find that you have a z-score of 0.92. Now that we also now have a z-score, we can solve for our standard deviation. Let's plug everything in. So 0.92 equals my x value, which is 65, minus my mean, which is 60, divided by my standard deviation. All right, let's clean this up a bit. We got 0.92 equals 5 divided by standard deviation. We're going to manipulate this formula, so we're going to switch the sigma and the 0.92. And now we can plug this into our calculator. What I have for my final answer, and I'm going to round, actually, you know what? I'm not going to round. It doesn't ask me to, so I'm going to leave my answer unrounded. What I have here is 5.4347, and there's some decimals after that, so I'll put the dots, and my answer is going to be in percent. So the standard deviation for this exam would have been about 5.4%. This is a very brief introduction into z-scores. I hope it helped. Have a good day. See ya.